In this video, I wanted to show you a few things about the postcranial skeleton in the duck-billed platypus monotreme compared to a therian mammal. And I'm going to start with a very nice mesh that I will acknowledge to the University of California at Berkeley, and in particular Carol Spencer, who uploaded this mesh. It's on morphosource.org. The link is in the credits. And there's another mesh of a tenrec that I'd like to credit to Cody Thompson at the University of Michigan, also linked in the comments to this video. In a monotreme, there are a couple of really interesting differences in the postcranial skeleton, and I could start with the shoulder girdle, in particular the scapula. Now, if you're used to looking at human scapulae, or dogs or cats or cows, any other therian mammal, this looks strange because it lacks a scapular spine. That's the external surface of the scapula right there, and here you're looking at the internal surface, and this is not divided, at least not as obviously as it is in therian mammals, into a supraspinatus and infra-spinatus fossa. There isn't really a scapular spine as it occurs in marsupials and placentals. Another striking difference is that shape of the humeral head. Now, this is a mesh of a somewhat juvenile specimen where the epiphysis isn't completely fused, and so the scan and the mesh didn't pick up all the tissues that would have comprised that proximal humerus. But look here where the humerus articulates into the glenoid of that scapula and the rest of the shoulder girdle. It's quite narrow, and it has this elliptical shape, right? And that's we'll see in the therian mammal. That's quite different. Another really big difference in a monotreme, both the platypus and the echidna, compared to a therian, has to do with the number of elements that you see in this ventral aspect of the shoulder girdle. We have a number of coracoid elements. There's one there. Here's another one here. And then we have a structure called the interclavicle, which is this T-shaped bone here. And none of those elements are present in a therian mammal. What you have in common with the therian are the clavicles. There's one there, and then of course the scapula itself, and also the manubrium sterni, or just the manubrium. That's the very cranial part, the top part of the breastbone. Now let's look at the hind limb. One of the differences with placental mammals is the presence of epipubic bones, and that's what you're looking at here. This is an incompletely fused os coxae on either side, or a nominate bone. That just refers to either half of the whole pelvic girdle. And what you're looking at here is the ilium, that's cranial to where the femur fits into the hip socket, or the acetabulum. You have an ischium, that's caudal to the acetabulum, and then we have a pubis. Monotremes have in common with marsupial mammals the presence of these epipubic bones. Living placental mammals do not have epipubic bones. And then the last major difference I'd like to just briefly mention here has to do with the orientation of the femoral head. This is true in both the echidna and the platypus. You're looking at the specimen, of course, a platypus. And the key anatomy I'd like you to notice is that femoral head is really sticking up out of the femur parallel with the long axis of the femoral shaft. And we have a greater and lesser trochanter on this platypus skeleton that are similar in size. They're not identical, but they're similar in size and sticking out pretty much just on either side of that femoral head. Now I'm going to switch to my therian skeleton, and this is the University of Michigan specimen I mentioned a moment ago, thanks to Cody Thompson. It's a tenrec Setifer setosus, and let's just start with that pelvic girdle. So first of all, it's a placental mammal, so you don't see any epipubic bones, right? They're gone. All you see is a pubis and an ischium, caudal to the acetabulum, and an ilium, which is cranial to the acetabulum. And then I mentioned that orientation of the femoral head, and it's not as obvious as I perhaps would like here, but I hope you can see that is not really coming out at the same or parallel to the long axis of the femoral shaft. It's coming out a bit at an angle, and also the greater and lesser trochanters of that proximal femur are not symmetrical. They're sort of the lesser trochanter is a bit offset relative to the greater trochanter. So that's the hind limb. Let's look at the forelimb now. And compared to the monotreme, that's much simplified. So like I said, there is no hint of an interclavicle. There are no separately ossified coracoid elements, at least not here. Here is the manubrium sterni. You can see the first ribs on either side, and then here are the two clavicles. But no coracoid elements, no interclavicle. And then the other huge difference that I hope is immediately obvious is the scapular spine. So because the head is down here towards the bottom of the screen, that's the supra-spinatus fossa, cranial to the spine, and this is the infra-spinatus fossa, caudal to the spine. And then lastly, I wanted to point out the nature of the humeral head in this therian mammal, this placental tenrec, and you can just make it out here, articulating in the glenoid of the scapula, and that is a very spherical humeral head. I hope you will agree, rather different looking than the humeral head that you may recall in the monotreme.